All right.
Yes.
So let's get started. So I'll tell you a little bit about what you're going to be doing now. So your first task, you're going to be converting an implementation of the try data structure from Java to Python, and you'll do this one without the AI support. So then
Okay.
your second task, you're going to convert an implementation of the priority queue data structure from Java to Python, and you'll do that one with the AI support.
I
And we'll
see.
take a break between the two tasks, to stretch your legs. Since the session, it will take the full 2 hours.
Okay.
Um, so let me tell you a bit more about the code translation task. The task is to produce a complete and working Python translation within 30 minutes.
Okay.
By complete, I mean that all of the functionality, all of the documentation from the Java code should be translated. And by working, I mean that the Python code, it should work, it should be tested for correctness, it should do the right thing.
I
Um,
see.
but as I mentioned before, there's more work for you to accomplish an absolutely perfect translation than what you can actually do within 30 minutes. So really what I'm asking you to do is just do as much as you can in the time that you have. But there might be trade-offs in how you spend your time, such as whether you choose to translate all of the functionality first and then test it, or if you translate a portion of it while testing it to make sure it works. How
I
you
see.
navigate that trade-off is entirely up to you.
I see.
And then a couple other things I should mention. One is you're going to use an online version of the VS Code editor.
Okay.
It's very similar to the desktop app, but it does have a few minor differences. Um, in general, all of the menu commands are available. All the keystrokes should just work. But if you do have sort of technical problems with VS Code, just let me know and we'll try to figure it out.
I see.
But I won't be able to answer any questions that you may have about the code or about what the code is supposed to do.
Okay.
Can tell you that the Java implementation is correct.
Okay.
Um,
So, so I have a
oh,
couple of questions here. Yeah.
oh,
Can I
sure.
ask? Yeah.
Yeah, yeah, yeah.
So,
Yeah, go right ahead.
yeah. So when you mentioned, you have an AI support system, does it mean that the AI system will actually do the conversion and then the user's job is to go over the Python code and then, fix the bugs, or does the support system, help the user, as and when they are coding it? That's the first question. And the second question was, like, also the conversion depends on the user's, knowledge about the underlying thing, right? For example, in this case, tries, I don't recall immediately. I might just have to do like a quick lookup of that.
Mhm.
So how should I proceed? Should I actually recall the try code by looking at the Java code, or by looking at, or let's say, should I just read a little bit about it, before we jump in?
Yeah, so I don't want to say anything about how you should go about doing the task,
Okay.
because
Okay.
for us, part of it is to understand how you would go about doing the task.
Okay.
But I'll say a little bit more about what exactly this AI system has done when we get to the AI task, since,
Okay.
we'll do the first task since that's without AI, and then I'll explain
Okay.
a little bit more about like what the AI has done for you. Um,
Okay.
but I don't want to say anything to shape how you perceive the system or how you might work with the system. We really just want to present it to you and sort of see what you do with it.
Fair. That's fair. No, so
Okay.
that's fair. Yeah.
Okay. So a couple other things about these translations. When you make the translation, please do try to preserve the naming of things like class and method names, but for things like variable names, we're less concerned with that. Um,
Okay.
and also, as I mentioned before, you can use whatever resources you feel would be helpful. So if you need to search the web, if you need to search Stack Overflow, those are all okay. If you need to run the code, we've installed Java and Python on the machine, so you'll be able to run code. And then I'll give you a 5-minute warning when time is almost up, just so to start wrapping things up. Uh,
Okay.
and then the last thing that we ask is that as you work on the tasks, we'd like you to sort of think out loud and like tell us what you're thinking, tell us what you're doing, because it really helps us understand like how you're approaching this task and what you're doing and like where you're stuck.
Okay.
So there might be some times like if you get quiet and if I'm confused about what's going on, I might, come on and just say, hey, what are you thinking right now to get you, talking again. So
Yeah. Sounds good.
good. So do you have any other questions before we get started, or?
No, I think that's it. Mm.
Okay. All right. So let me hold on one second. What the hell? I just need to check one thing.
Yeah, yeah,
I said we're going to do the try first without AI support. But now my
that's
notes
correct.
say we're going to do AI first with the priority queue. So let me just double check I'm doing this in the right order for you.
Okay,
We are doing the AI, oh, we're doing the AI task first, and it is the
I
priority
see.
queue. Okay.
I see.
So
Okay,
I did the instructions backwards.
okay.
My apologies.
No, it's okay. It's okay.
This is one of the things I was afraid of. Okay. So we are going to do the priority queue first with the AI.
Okay,
So I guess I'll answer your question sooner rather than later.
okay. Yeah,
So let's see. So you'll, as I mentioned, you'll translate the priority queue from Java to Python with the AI. So what the system does is it's able to automatically translate code from Java to Python, but the system is not perfect. So the translated code it produces may have errors in it. And what we've done ahead of time is we've created 5 separate Python translations for you from the system, which you'll see when you open up the code editor. And how you use those translations to complete the task is entirely up to you.
I
So
see.
let me send you the link to the editor.
Yeah,
And if you could open that up and also maybe share your screen.
yeah. So I'll start sharing my screen now.
Yeah, that would be good. Thank you.
Yeah. So let me just open up a new window.
Okay. And in, oh, okay. So in Firefox, yeah, okay, you're already ahead of me.
Yeah.
This is just like we've signed the certificate with the IBM root cert, and Firefox is still not happy with it, but
I see. That's okay.
yeah.
Yeah,
So, okay, so let me just, quickly point out on the left, there's a bunch of files in here. So priorityqueue.java, that's the original Java. Priorityqueue.py, that's the file that we ask you to put your solution in. And then
I see.
the five other Python files, that's what the AI system has produced is 5 separate translations.
I see. Perfect.
So now I'm gonna push the start button on the timer and let you get to work.
I see. Okay.
And also just a reminder to sort of talk as you're going through so we have an idea of like what you're
I
thinking about
see. I
doing.
see. So, yeah. So my first thoughts are to just read the Java code once and see how exactly it's implemented in the priority queue. So I'm planning to read the comments. Maybe and then also look at a higher level structure. For example, the classes and the methods that are implemented. So I want to first get a higher level idea of the Java code before I jump into the actual implementation. Yeah. So I'm actually planning to read the comments now. So I see. So I see that so the queue kind of works with any kind of element. So there's a public class. It has a constructor, and then you can also add elements to it. I see. So remove it. Okay. So it removes the highest priority item. Okay. And then so let's put insert. So this for checking the size of it. This is to get the first element. Checks for emptiness. So basically returns all the elements. It adds a bunch of elements to the priority queue. Okay. Okay. So it's talking about some heap properties. Yeah, so the first thing was like I was expecting along with the class implementation, there will be some main method on which we can run and execute, but I see that we don't have any such main methods. So I guess it makes it a little bit challenging now because we cannot test immediately. Okay. Okay, so I'm just gonna. So now I'm actually planning to look at the 5 implementations and see at a high level whether does it have all the methods or not. So I see inserts, remove size, entity, and merit. Okay. Hmm. Okay. So now I'm just a bit curious here. I'm just planning to see, where exactly do these things differ. Mm. Yeah, I guess I'm doing the comparison mainly because like the first choice is when we are given the 5 items, it might be better to know from which thing to start with. So, my first priority is to also uh, pick whether should I start with the first one where, probably that might be the best preference for the system, or to see, if there's a better candidate on which I could start with. Mm, okay. See. Yeah, so I noticed this is, one of the way in which you define the arguments. Okay. Yeah, I mean, yeah, I think I'll just start with, with priority, with taking the first implementation of one. So maybe what I'll do is I'll just copy, yeah, maybe before copy. Yeah, now I think I'll just check it at a method level, how does it work from the Java code to the Python one. So yeah, so now so it takes any element for comparison. Let's see. Okay, so even it does an item. Yeah, I think the constructor I think is looks correct. So I'll go to the next method, which is insert. Um, so I see that now, when we want to insert a new element, we are first adding it, and then we are doing a binary search and finding the appropriate position for the item that's about to be inserted. Okay. Yeah, I have a feeling this would throw, you know, an index error. So let me just do. So, okay, interesting.
So what's interesting?
Like I see the two this one, right? So I'm just curious, whether this reminds the quotient or, as a reminder. So I just want to test it now. Okay, I see. So, okay, so just getting the integer. That's fine. Okay, because that's the position, so this should be good. Um, so if parent is lesser than this one, so then what you're doing is you're doing the heap dot set. So if the item is lesser, then you are updating it there. Okay. Okay. So the same index you have. So that looks correct. Index should be fine. No, that's the parent. Okay, and then you have check index equal to parent index. This looks correct. And then you keep checking. Okay. Okay, so at least I can tell now that this implementation is accurate to this implementation. So this will compare. Okay, that's fine. So now I'll stick to the remove method, remove the highest priority item. So yeah, the way I'm actually planning to do this is I'm planning to go at a method by method level. So now, I've checked the index method and the constructor, they both look correct. So now I've moved to the remove method. Yeah, in fact, I just realized now, I can also add my sysmain methods into the Java code and then the Python code to test it. Yeah, I think the way I code is I first look at the code and then I come to the test cases. So I'm planning to go over all of these methods and in the ending, add explicit test cases to test the individual methods. So if we remove, checks this for the size. So it removes the highest priority item, which is the one at the front. Okay. So getting the element. Swap the last item in for the first. Remove the highest priority item for the first. Leave dot remove index. So and then okay. Remove the highest priority item from the priority queue. Then so you're doing a heapify. And then also remove the element. Okay. Yeah, so this check is fine. Index equal to heap dot size minus one. So you're getting the first element self dot heap. And then you're doing an update. So what you're doing is the first element, you are equating with the last element. Yeah, that's fine. And then you are removing the last element. That's also fine. And then you're calling the heapify method internally. That's fine. And then you're passing the heap and then the heap size. That's fine. And then you're calling the element. Okay. Yeah, I mean, that looks correct too. Okay, so I'm just gonna count now how many times. Okay. I still have 20 more minutes. Okay, so size, this should be easy. heap dot size, return heap dot size, length of self dot heap. Okay, I think pop seems like a mistake. Let's see. Yeah, pop seems like a mistake. Mm. Yeah, I wonder, in fact, this might be a problem, even in the Java implementation. But yeah, I'm gonna, take consideration into fact that, as you mentioned, the Java code is correct. So, okay. So yeah, it should not be a pop, or rather it should just be, if it's not empty. Yeah, so I mean, okay, yeah, interesting. So next check for, yeah, I see. Okay, so I don't think Python list has this method empty. So what I'm gonna do is return length of self dot heap to 0. So yeah, if it's 0, that's true. That's true. Yeah. Enumerate, provide all those in the priority queue in order. Okay. Let's look at this enumerate. Okay, so let's see what this code does. So creates a new array list, creates an empty list, and then if the heap is not empty, okay, it basically adds into that list. So it basically calls the remove method. Provide all the results in the priority queue in order. Return a list of all the results in the priority queue. I see. So heap is saved heap and then return results. So heap is its internal data structure, right? Yeah. So, so what are they doing here? So they're calling the remove method incrementally, and then they're adding it to a list. So remove, it removes the first element. Hmm. Okay, so there should be an exact copy enumerate. So copy dot deep copy. Okay, so that results. File not self dot heap dot empty. Okay, results dot append self dot remove. That should be fine. Yeah, I mean, in terms of results, I think again it looks correct. Okay, two methods: add all, collection. Yeah, that looks correct. Add all. Yeah, that looks correct. Okay, now heapify. Restore a section of the heap to maintain heap properties. Around the point on the heap to work on, if the indicator point doesn't have the proper relation to its descendants. The values are swapped and the dependent different process recursively. The heap properties, the point in the heap to work on, if the indicated point doesn't have the proper relation to its descendants, their values are swapped from the descendant is then proceeded recursively. Okay, let's see. So you have an index and you have a size. The size is greater than 0. What you're doing is it's into 2 plus 1. Let's say 3 into 2 plus 1, 3 into 2 plus 2. Okay. left index, right index. Just to multiplication. Yes, exactly. Okay, this is interesting. Okay. Left index, right index, parent, heap dot get of index. So we get the element at that index, and then max index is index. I see. So you basically give the current position and then do a heap size. I see. Okay, so it checks for the left index less than size and heap dot get of left index compared to. Okay. Okay, I see. So let's look at line by line. Size less than 0, left index equal to index into 2 plus 1, right index into 2 plus 2, parent equal to heap dot get of index. Okay, that's also fine. The max index is index. Okay, size dot heap of left index greater than parent. That's a NAND, and compare is actually greater than 0, left index to parent. Okay, that looks correct. Max index equal to left index. Right index less than size and heap greater than right index greater than greater left index. Okay, max index is right index. Max index is not equal to index. Okay, so with the set of index, get of max index. So you're setting the value in this index with the max index. Okay, yeah, that looks correct. And then you're swapping the max index to the parent. Okay, and then you're doing heapify. Okay, I think it looks correct too. Okay, perfect. Yeah, also, so the way I'm actually doing the verification is, frankly, I think at this point of time, I still need to understand, this code a little bit better. But at least, if I look at line by line, I can see that, the A generated code, at least correctly did the transformation. So yeah, I mean, that might be one of the perils where it might not be able to understand the code correctly, but if you know both the languages, I can at least tell that, implementation wise it does do the right job. So now I'm going to do some sort of testing. Okay. So now my plan is to go over each of these methods and then check, if everything is correctly, is at least working the way I wanted without any errors or not. So yeah, I mean, I actually don't like capitalization on the lower cases. TQ, just gonna call it that way. TQ. So I'm gonna first create an object. So what I'm gonna do is first check if the queue is empty. I'm just gonna call the empty method here. Yeah, let's see if that works. I see. Okay, perfect. So okay, it's working here. So I'm just gonna, yeah, I think this is where I wish, Java has the sysmain thing. Java. All right. Public static void main string of args. string of args, and then system dot of dot println test. Okay, now let's see. I see, understand it. Yeah, cool, perfect. So now let's look at it is compiling. That's good. Perfect. So I did print the test. Now I can start testing both of them simultaneously. Okay. Priority queue. Priority queue. Let's see. Yeah, so it's been some time that this user has coded in Java. So let's see. Hope I don't spend much time here, but yeah, let's see. Okay, I should do a new movie. Right. Okay. So what is the complaining? Nah, yeah, let's change it to queue. Okay. Okay. The value of the local variable q is not used. Of course, I have not used it. System dot out dot println, and then I'm just going to do q dot empty. Is empty. Yeah, let's see now if this guy works. Why is an error? Okay, so I did have an extra bracket. Interesting. Syntax error, delete this token. Okay. Okay, so let's see. So what does the isEmpty method return here? It's a boolean. Okay. Yeah, I mean it is correct. I don't know why it's interesting.
Just so you know, we got about 5 minutes left.
Okay, 5 minutes left. I see. Okay. Okay. So now, okay, now let's get right into it. Let's write a test case for each of these methods. Okay, let's start with insert. Okay. Do not insert 3. Do not insert 7. Do not insert 0. And then some dot on println dot so. Okay, so q dot, yeah, I think let's also, yeah, so it might be a good thing is to add also, yeah, insert 3, insert 7, 370, right? All right, and then do pre q dot size. Yeah, there is a size method in here. Perfect. Okay, so now that will test for the size. I'm just going to test it. Interesting. Perfect. Okay, so now let's see. So we tested insert. Let's test remove. Right. Okay. So how should we test remove? So remove. Yeah. So basically, you don't get this one, right? So you do this, and then you do system dot dot println q dot what was it method that inspects enumerate. Let's see. Yeah, is it because, yeah, okay, figured that one. All right, so when was, to write this for loop? Okay, so maybe before that, let's get this guy. You dot remove, let's do this, and then do print dot q dot enumerate. Yeah, let's see what this guy returns. Actually, I don't need all these things, but it's okay. Can only concatenate list to list. Can only concatenate list to list. Interesting. Ah, I see. So self.ep5 line 42. Okay. Okay, so this one got neat. I see. So ep5, you have an index there, that's fine. Okay, so you have list index out of range line 83. Oh, okay, so that's interesting. I don't remember seeing an index -1 there. Isn't indexing also start with 0 in Java? That might be a big thing if I missed. Yeah, it is zero-based indexing. So I'm surprised if it works here. Why doesn't it work here? But okay. So maybe line 42, there's a bug. You did pop there, so it should work. Okay, so maybe it's not the length. I see. It should be the index. Ah, interesting.
All right, I'm gonna have to call time.
Okay. Okay. Yeah, I know.
So if I could just have you do one thing is if you could select, because you were working in this file, right? AI1. If you could just select it all, copy it, and then paste it into priorityqueue.py.
Yeah,
Thanks.
that's it, right?
This,
Yeah,
yeah,
perfect.
this is the one we're going to be looking at for the solution. So,
Okay.
okay, great. So let me send you the link to the survey.
Okay.
And
Yeah, so I think I have some questions which I think I'll ask at the end of the survey.
yeah, sure thing. And then you can also close this browser window. It's
Oh, okay. Okay. So I'm coming out of this one, right? Yeah.
yeah, close this one because you'll open a new one for the next task.
Okay. Yeah. So is it saved, right? At your end, it's saved, right?
Yeah, it's saved. Yeah. It's saved.
Okay, perfect.
Okay. So for this, your participant ID, I think I said was P8.
Yeah. Yeah.
And then this was the AI priority queue. Also, it would help us to understand like the rationale rating it the way you are.
Yeah. Like I think for the mentally demanding, because we need to look at the corresponding Java code, right? And then we need to understand it, and then accordingly code. So that's why I felt like both the mentally demanding part was there. In fact, I was actually leaning to put the pace of the thing as at 10, but as when I started testing the code, because I started seeing some bugs, I realized, yeah, I mean, I think I should have taken a different approach, but yeah, which actually made me realize, yeah, the 30 minutes might be too less for the task. That's why I'm actually leaning towards keeping saying that the task was a bit rushed. Yeah, I mean, now after running the test cases, I would say, yeah, you know, I know it did not work. So at least because the code did not work, I know. So it was a failure. So I'm just gonna place it there. How hard did you have to work to accomplish your level of performance? Yeah, I mean, I think it's somewhere, I'd say, like, somewhere here. I'm insecure, discouraged, irritated, stressed, and annoyed where yeah, I wasn't, yeah, because you have explained everything to me, so yeah, I mean, I would say, I'm not very irritated, but yeah, I guess when I looked at the implementation of the priority queue, I think, yeah, there were some parts which I did not understand. It's because I didn't understand the Java code correctly. I'm actually, not putting a score of 1, but rather, I'm putting it at a 10. Yeah, because I think some of the insecurity actually came because of not having not able to understand the Java code correctly. Because one of the things that you should do to do a right translation was, you should yeah, and understand the code. Because yeah, like I think the way I did it, if I was mainly looking at the Java code and then trying to translate it to Python, the code seemed correct, but I think, yeah, I mean, I missed some of the things, like, things which check the length of the list and so on. So, I'm gonna keep it at 10. Please describe your overall approach for how you worked on this task and how you allocated your time across different activities. I wanted to do the translation at a method, at a method level. So yeah, so I was in each method. My approach was to compare the corresponding code between the two languages, line by line. Yeah, so after finishing this, I spent the remaining time on testing the program between the two languages. To ensure that the translation code is correctly working. To what extent do you feel you understood that? How did yeah, I mean, I think it's somewhat, why? I think it's partially, it's, I mean, the data, you remember the data structure. I think you just have to read up a little bit. I mean, at a higher level, you know what the priority queue does, but what is the best way to say this? Properties of the priority queue. Okay, next. How would you characterize the quality of the provided translation? I would say it's very good. Why? There are no obvious mistakes. I mean, first of all, syntactically, syntax looks correct. Yeah, next, line by translation part, line by line translation looks reasonably correct. Okay, next, what else do I look at? The translation translation module, the translation AI module neatly created a corresponding method for each of the underlying methods, Java methods. Yeah, what else? So you look at the syntax, you look at the code quality, translation. What else do you look at? Yeah, I mean, comments, I didn't, comments, did not look at them, did not look at generated Python comments. Didn't get a chance to deeply look at the generated Python comments, but they did look good as far as I remember. How did the quality of the translation match your expectations of what could be produced? Yeah, I think the quality was better. You know, it's not much better because there are bugs. So if there are no bugs and if I had made zero corrections, then I would say it's much better. But since there are bugs, I'm planning to say it's better. To what extent did you feel the provided translations were useful? Definitely useful. Had errors? Yeah, helped you complete the task. Yeah, somewhat. No, I think I did not use the translation code to understand the Java code. No, I did not taught me anything. Did you feel that the provided translations made your work in this task difficult? It was very easy. I would say it's very easy. One, I would say it would have made my task difficult because if the code has produced, let's say, a garbled Python code, and if I had to make too many modifications, at least to get the structure correct, I would say it was very difficult. But the one that I started looking at, it was well organized. It looked reasonably correct. So definitely, I would say, it made my job much easier. Did you feel that the provided translations made your work in this task flow? It was very, it helped me in actually completing it. Did you feel that the provided translations made your work no, with this quality? Well, you found, I think it gave me a good start to begin with. I would say that's the most useful thing. What did you find least useful about the provided translations? No, I'd say nothing. I mean, I think most of the translation code seemed useful. I would have liked to have seen more translations. No, I mean, I think that one of the problems also is in 30 minutes, it's kind of hard to look at, each of these translations and then make a judgment. So I would have liked to see with lesser translations to begin with. I would say start with enough translations. Additional information. Yeah, I wish there were also test cases. This is in Java and in the generated code that would have significantly helped the end user uh, to verify the translations. To verify the translation at a faster pace. With the following work conditions, to what extent would I support code normal working conditions? No, I mean, I think it's helpful. When under time pressure, no, still I think it's it's very helpful when working alone. Normal working conditions, when working alone, working in code that only I would use. Team members are available to do it's the same in a small team. Doesn't make any difference. Yeah, it doesn't make any difference. Overall, I find it to be useful. So as of now, I cannot say it's extremely helpful. So that's why in all these metrics, I'm actually leaning towards just saying it's helpful. But what situations would I support it? That should be appropriate. No, mission critical, I definitely wouldn't trust. I mean, even though it looks good, just I wouldn't trust it. The code correctness is important. Yeah, I just with this code's runtime, no, because it might not be efficient. We definitely need humans to do the runtime part. When there is a large code base, definitely. When there's a large code, yeah, again, if there's a large code base, if you have an AI system, yeah, it can translate, but to find the bug, that can be very, very intimidating. So, I don't know. I just would stick with this, with which I'm unfamiliar. Yeah, I mean, if you're unfamiliar with the original language, I would prefer this one with the test cases. If there are test cases in the other language, then I would definitely want the AI system to generate, the starting code on which I can work upon. And here I'm not, how useful will each of these kinds of AI models be for real code translation? Like, yeah, I mean, here that's definitely, yeah. I mean, here I would start to, yeah. I mean, it's just not useful. Yeah, I mean, I wish there are some test cases. It would help me in focusing more on the translation part. Yeah. So Justin, I think those are my comments. Yeah.
Good. No, that's great. That's fantastic. So why don't we take a couple minutes break and then we can do the second task.
Yeah. So overall, I mean, is this the time I can ask the questions, or
Um,
or would you
maybe
prefer?
maybe let's save questions till the end. Just, again, I don't want to sort of spoil things.
Definitely,
How you're
and I
working.
can understand. So
Yeah,
yeah,
but
I'll just take like 2 minutes break, and then we can start the next one. Yeah.
yep, exactly. I'm also going to take a break, so I'll
Okay.
be back.
Sounds good. Yeah. So I'll be on the mute. Yeah, I think I'm ready to do the next one. This
All
one might be a killer,
right.
I'm a bit intimidated, but I think, I don't mind. Let's jump in. I
Yeah,
think,
let's jump in. Yeah.
I got a flavor. I got a flavor of what I've signed up for.
Well, this is why we do both, right? So you can compare both
Yeah,
experiences. So yeah,
I'm
so
actually, yeah, I'm actually very glad I got to do the AI one.
all right. So in this one, as I mentioned, this is going to be the try data structure translate from Java to Python without the
Okay,
AI support. So let
okay,
me send you the link to this one.
okay. Yeah, I got it. Let me just open it, and then I'll share my screen.
Yeah,
Yeah.
and please share your screen.
Hmm. Right. So when does the time start now? It started
I'll
already.
let you know when I start the timer.
Okay.
But same
Please,
deal. You have the original source Java, and then just please put your Python in that blank file.
I
So
see. Perfect.
I will start the timer right now.
Okay. Okay. So let's look at the number of lines. Okay, 170. And again, so let's get an idea of the outline. So yeah, it has basically a bunch of methods. Yeah. Okay. So okay. Okay. So it's this one. I see. Okay. So try class. This class implements. So yeah, now because we don't have anything to start with, my idea is to first understand the codes, and maybe start translating it method by method, So yeah, I think also I found it convenient to have a test case. So I mean, this might kill my time, but okay, you know what? Let's. But I think I might need this public static void main string args system dot println test. Perfect. Okay, so I'm just first gonna get the syntax right there in both the places. Okay, so yeah, class try, and then now it's gonna be the standard init. Okay, and then just do a pass, and then here just so I'm creating an outline in the Python code. In fact, like now I'm actually leaning more towards testing it, as in when I code. So you might expect now to see more tests, in this one. Perfect. So let's see. So it's gonna do print test. Yeah, perfect. Okay, so let's look at blah blah blah. This class implements a try object for the storing and retrieval of strings. It basically builds a tree of nodes where each node represents a character in a string that has been stored in the try. A stored string is represented by a path in the try from the root. Yeah, okay, that's familiar. The try node class is used by the try class to store individual nodes in the tree. I see. So each node represents a point in a stored string under the set of children nodes, which has okay. 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 So basically, now I see that the try has an internal class, try node, and then as try has is like a binary data structure. So it is using the try node class to represent each node. Okay, so we can do the same thing. All right. Mhm. Class try node, and then let's see. So what are the so you have a try node class. Basically, you have a constructor, you have an insert, you have a find, delete, delete, enumerate, merge. Okay, so it's basically a bunch of methods. I see. So so I'm thinking now because implementing a try node is going to be so common. So maybe I first start with implementing the child class try node. Okay, so what does it have? It has a hash map. It has a Boolean property, constructor. Okay, a method, a method, a method. Okay, I see. Okay. Okay, perfect. Okay, so constructor, it's not taking anything else. Okay, so let's see. So now we need to define a children and his word. So let's have the same convention, naming convention for the variables, children. So hash map is like a dictionary. So they are creating a new dictionary with character and a trinode. I see. Okay. So it's a dictionary children, and then you have a Boolean is word. So yeah, I'm sticking with camel case in Python because that's the default convention. Okay, so the constructor is fine. Now let's implement the method get children. Okay, so define get children. Okay, because it's a class method, I'm just gonna do self, and then I'm just gonna do. Okay, in fact, let's do this self dot children, self dot is word, return self dot children. Okay, so we have got that method. Now let's look for is end of word. Okay, is end of word. Self return self dot is word. Okay. Wait, so yeah, so this is a boolean as well. Now this is set end of word. Okay, so it is taking an argument. So let's add an argument. What does the argument say? Is end of word. I see. Is end of word. Perfect. Yeah. So let's see whether that is complete or not. Yeah. So you have constructor. You have three methods basically. Constructor. I think this looks correct. No. Yeah, I think that is correct. Children is what? You have a constructor, return self dot children is under what? Okay, that looks correct. Okay. So yeah, let's test it soon. So in this constructor, you are basically creating a root node. Okay, so perfect. So let's also do the same thing. So try node. Perfect. Yeah. So let's first also add a method which gets the size, and then maybe we can then test it. Insert, find, delete, enumerate, merge. Okay, there's no. Okay, of course, because it's so size. Okay, maybe first let's just test this one so far. No. So I think we didn't test this one so far. Perfect. So that did work. 1.3. All right, let's see. So init takes 0 positional arguments, but one was given. Where is it? 923. What is it saying again? Oh, self. Okay, final is not defined. Yeah, so this is interesting. Yeah, I don't know if we can define Python define inner class. So okay, but there's no inner class there. Class color. I mean, he did define there, and if that one is working, okay, maybe should we do it later? I guess. Okay, interesting. Let's do this guy. Yeah, now let's see if that works. Interesting. Try node. Try node is not defined. Okay, what is that? Oh, redo self dot light green, is it? Self. Perfect. We got that one working. Okay, so the first part is done. Okay, now let's look at method by method. Okay, so the try node is done. Okay, so we did define a root node here. Yeah, we did define a root node, so that is done. So next look at insert method, insert a string into a try. Okay, so you have a word, finite current. Okay, so 10 minutes. So what does that do? So basically it is iterating on its character and okay, so it says current is the root node and then it says, so it's basically, it's getting the children and then checks if compute, if absent, okay, then it is inserting a new try node. I see. Okay, perfect. So for insert to work, we need to implement a get children method and wait, this is already there. Well, that's a hash map, get children, current dot get children, right? Because that one returns a hash map. Okay. On the hash map, we have a compute if absent. Okay. Um, okay. So let's see, let's check if this guy is there. Okay, so it's not there. I see. Because this is a node, so this one returns a dictionary hash map. So what they're checking is compute if absent. So it is there is a key. What it does is blah 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 and null. Okay, but what it should do is new try node compute if absent. So basically, if the character is not there, what it should do is so it should add a new node. Yeah, because it so basically what it should do is it should return the node corresponding to the current character if it's available, right? So if it is not available, it should create one. Compute if absent. So what does this one do? So there's a key, there's a Java idle function, super k extends v mapping function return null. Okay, but what is the C here? Okay, okay. So this one, I think for this user, it's a bit hard to understand, but I think because they have a familiar understanding of how this implementation should work, I think I'll start with that. Okay. So you basically get the, okay, so what we should do now is insert, okay. Okay, let's just add it here. Define insert self dot word or C in word. Okay, now what it should do is, okay, so first now let's define, and again, let's just say current equal to, also let's just call it self dot root. Right, perfect. So current equal to self dot root. Okay, so now what you do is you basically update your current with. So what you should check is because it's a dictionary, right? Yeah, I mean I don't have to implement it right line by line. So what you should do is if C in current dot get children, well that's a dictionary. If it's already there, then your current would be. But you need to get that one right. Mm, and get children. That's a dictionary. You just have to do this. Yeah. So if it is not there, what you should do is you need to add something. But how do you add a children? Okay, so how do you add interesting. So okay, so there's no explicit method to add a children. Okay, so maybe we will just do that. Okay, so which is you first create a temp one, which is self dot try node. First create this one, and you should assign it, right? So what you should do is current dot get children of. What you should do is you should assign that character, which is C. But was it C there? It's actually L. Yeah. So for the current character, you need to assign this node. Okay. So for this character, you're gonna assign a try node, right? And then yeah, so it's basically C not in that one. All you do is you do this one, and then you can always take it like this. Let's see. So if the word is not there in the children, what you do is you add a try node to that one, right? And then your current one is you dot get children. Okay, I think that should work. And then you just say at the end of it, I see. Okay, and then at the end of it, you say current dot. What's the method? Set end of word. Set end of word true. Right, perfect. Okay, all right. So let's see if that is done or not. Okay, T, let's insert a word. Test. Okay, let's see if this works. Yeah, so now my plan is to, after implementing the first method, my plan is to make sure that there are no syntactical errors in this method, and make sure it works the way that you want it to work. Method object does not support as item assignment. Okay. Okay, so it's basically a dictionary. Okay, that seemed to work. So how can it test now? So insert seems to have worked. Yeah, so now, yeah, exactly. Now we need to test, so find is a method, find. So how many more methods are there? There's find, delete, enumerate, okay, merge, like 3-4 methods in 10 minutes. Okay, so find, test whether a string is stored in a tray. True if the string is stored in the tray, false otherwise. I see. Yeah, so you basically iterate and you check. Yeah, okay, perfect, perfect. Okay, perfect. Yeah, so it's fine. So let's do define find self word. Yeah, for C node. Okay, so let's also get get the root node. Current equal to self dot root. Yeah, so are we adding it to the root current? Yeah, because we are adding, I think. Yeah, let's see. So for C in word, okay, so you're trying to get it. Okay. So what's the variable that you use there? So it's in node. So node equal to current dot get children dot let's do this because it throws an error, I guess. Let's do this, right? Yeah. So now if node is none, then we know it's false. Perfect. If node is none, we know it's false. If node is not none, we just continue. Okay. If then current equal to node. Okay. Then you can then you also do that check. Okay. Written current is a node is in the word. Perfect. Perfect. Now let's just test. And they got find of test. Oh, cool. Now let's check. Awesome. Okay, so that is working. Okay, so we have now both test and find are working. So let's close this one. Okay, so now let's do delete. Remove a string stored in a tray. So if you have a word, what you're doing is okay, you're calling a method delete. An internal method you are giving in the root node, you are giving a word and a position. I see. So recursive delete method current is current node, string to be deleted, the current depth that we have descended. Okay. True, the string was deleted, false, it was not found. I see. Okay, so what you're doing is, okay, you start at one node for 10 minutes. So you have delete method, you have enumerate method. Okay, merge. Okay, let's come to that later, maybe. Let's do delete. So let's do delete, right? So what it does is, okay, so it starts with a root node, word, and then C. Okay, if index equal to the word length, okay, the current depth that we have descended, I see it's stored in the position, but the word also shouldn't it, uh, if index equal to word dot length, if current is not in the word return false. Okay, I would have done different implementation. Yeah, I think this is another interesting thing. For example, if the user has the background that is needed to know how should he delete it, so they might do it in a different way. But now, like, but rather than start coding this method delete directly, what I'm planning to do is I'm planning to understand the Java method and make sure I handle the same edge cases. So that might be more time consuming, but yeah, let me still proceed in that way. If index is word dot length, okay, yeah, maybe let's try this method coding line by line. Okay, okay, so let's do a delete method. Okay, so we give a word. Define delete, so dot word, and then what it does is, yeah, also, I mean, yeah, it's interesting. For example, if the evaluation is done in terms of how many methods the user has translated, some methods are fairly easy. Let me try to bias it in easily implementing the superficial delete and the enumerate methods. So you give root and word, I see, which is self dot root comma word comma 0. So let's implement the delete method here, where you get it gets, let's say, node. Here's, let's say, word, let's say index. Let's not implement it first. Let's go to the other method, which is enumerate. Enumerate the strings stored in the tray. Okay, so enumerate is a method. It doesn't take any arguments. What it does is now, okay, you define a list entries. Now what you do is you call the same method recursively, excuse me, in giving a word, and then you say root and entries. Okay, or equal to this. self-dot enumerate of word, and then you say root, which is self-dot root, comma entries, yeah, and then in the ending you have entries. So let's also define the other method, which is okay, 5 minutes. Enumerate self. So you basically take a string. Okay. I basically have entries as okay. Okay, all right, let's come to this. Okay, so delete. Okay, so let's come no, but okay, let's come to here. So if index equal to word dot length, current is not end up. Yeah, let's do line by line. Okay, so if index.
All right, we've got 5 minutes left.
5 minutes, yeah. If index is word dot length, okay, let's do line by line. If index is length, word length, okay, so if not, no dot, okay, let's use the same variable current. So current dot is end of word. Let's see. Okay, 1, 2, 3, yeah. So if not current, return false. Okay. Current dot set end of word is false. Okay. So that should be false. Yeah, so now the approach that I'm taking is I haven't really understood this code neatly, but I'm trying to do a line by line translation. Set, and then you're doing written, because I realized that might be more better, in this case, rather than me understanding the code, it might be more quicker to do the translation in this approach. Current don't get children not is empty. Current dot get children dot. Okay. Yeah, so now another thing that I'm realizing is some of these methods are there in the Java, for example, for the inbuilt Java methods. Uh, you know, we might not have those methods in Python sometimes. So that's going to be an interesting task for the translation program. Yeah, I mean, and for the end user as well. But he's empty, right? Let's check. So okay, so written, just do this. Should do it. Okay, now you are trying to get the character. Okay, so let's get the character at the same position. Okay, so next okay, you first get the corresponding node. And how do I get that? You do current dot children dot get ch. Okay, but are you doing a dot uncheck? Okay, you're doing an uncheck. Okay, so let me do this way. Get ch comma none. Now, if node is none, then what does it do? Return false. Okay, then okay, so we have another method boolean. Should delete current node. Okay. Okay, I see what they're doing. Okay. So you're calling the same function. So delete, and what you're passing is you're passing node, okay, which is this one, and then you're passing word. Okay, interesting. You're passing the word, comma index plus one, comma index plus one, and then there's an and no dot is in the row. So now if schedule current word, current dot get children, get children dot get what's the character? Okay, just remove ch. That's a dictionary. Okay. So what I'll do is del, because it's a dictionary, just do ch, and then I'm going to do this. And then what's this last line? Okay, so it's written an empty. I see.
All right, and that's time.
Okay, yeah.
So,
I
okay.
know, sorry. Yeah,
Yeah.
so I
Okay.
think I'm
Yeah.
good.
Okay. Good. Let me send you the link to the next survey.
Yeah, yeah. Actually, I have, yeah, let me answer it in the survey. Yeah,
Yeah. Okay. And you can also close this window now.
perfect. Yeah, you got it saved, right? Yeah. Perfect. So yeah, you'll be sending the survey, right?
Yeah, it's the same link.
Oh, it's the same link. Should I just
It might work better if you close this window and just open it up in a new tab,
perfect.
just so it captures it as a separate response.
Yeah.
Okay. So again, you're P8.
Yeah.
And this
So
was
no
called
AI
try.
and it's a try.
Yep.
Yeah. How mentally demanding was this task? Yeah, same demanding as the last one. I would say same pace. How successful? In fact, now I actually feel much more comfortable. So I'm actually leaning more towards, giving myself a higher score, which is very bad in the sense that, the quality of my feeling was, with the AI system, I did good job. But if I look at it at a binary point of view, because there were bugs, I kind of kept as a failure, maybe because I had higher expectation there. In this one, I had frankly low expectations. And since I was able to, at least code 3 or 4 methods, I'm actually scaling it here. Yeah, but I just find it a bit unfair for the AI system to have given this code. How hard did you have to work to accomplish your level of performance? Yeah, man, it's reasonable. How insecure? In fact, this time I wasn't at all because I got the things flowing, So, this might be better. Mm. So first, I understood so the number of methods that are to be translated, and then I started translating method by method. But yeah, I mean, so I allocated the way yeah, I mean, so that's obvious. I allocated my time. To what extent do you feel you understood how the Java implementation? Yeah, I think I would say it's somewhat because I have not looked at the last methods. Why? On the methods that's that I translated, I understood the Java code, but on the methods that I haven't translated, I did not, obviously, I did not understood that. Yeah. Their feedback. Oh, that's it. Okay, interesting. Yeah, I mean,
This one's a little shorter.
I see. Yeah. I think overall, I feel it's only fair to have the same underlying task, same or closer underlying task, uh, same underlying translated, same underlying task in both the approaches, AI versus non-AI, because the coders recollection or understanding of the background can have a significant impact on doing the translation task, on doing the translation. Also, it's also the task that you take in the first. So the tasks, the first task, and also the familiarity with the task significantly improves with respect to the second task. And that significantly improves so might matter which one the end user is starting with. But overall, I definitely pleasantly surprised the quality of the generated AI code. Not bad. Not bad. That was very quick.
All right, one more survey, but you already kind of
sure.
answered some of the questions. So this last one is supposed to ask these questions about with AI versus without AI, but you already kind of got at that. So
I see. Yeah. Curious.
but yeah, again, P8.
P8, yeah. How would you compare your experience working on the translation task without AI support versus with AI support?
I mean, if you want to tell me to just see your previous answer from the other survey.
No, it's okay. Like, because I'm also trying to, take more time to see, to actually, put out more words or something. I think it's okay. I if you don't mind, I can actually again.
Oh no, absolutely. Oh, that's great for us. I just
yeah.
I didn't want you to feel like you had to repeat yourself.
I see. Okay. Yeah. I think with the AIs. Becomes much easier and preferable to work with. Frankly, no. AIs in general, AIs, the quality of the AI support all is greater than some threshold, the user might find it convenient to work with the AI support code. In my case, I definitely found the AI support code to have crossed threshold. Yeah, yeah. I think this one kind of like summarize it better. Yeah. Yeah. So beyond code translation, what other kinds of AI support would you desire for working with code? Mm, so apart from code translation, okay. I mean, and there are obvious code filling tasks that people are currently working on. Apart from code filling, so code filling, where the AI system tries to give suggestions to complete the code. Next one is
So when you say
error.
code filling, you mean like an autocomplete kind of thing?
Yeah, exactly. Yeah. Yeah, I mean that might be a better term to use. Yeah, bug fix catching. So, mm, um, it is useful to have an AI system to catch and warn errors like something like where A is not defined so far, So that's one kind of an error. And
Well, actually, let me push a little bit on that, right? Because things like that, if you try to assign to a variable that hasn't been defined, I feel like current tooling does that already, right? Like we have linters that will check for those sort of simple error cases, right?
okay. Yeah. So yeah. Okay. Then maybe that. So
So,
I have actually used Pylint at a higher level. I mean uh, okay. So I mean if you say okay then maybe I think I didn't know that, or maybe I didn't realize that. Okay, I see. So because what I know Pylint does is at the end of the code you can run your script and it does some sort of type checking and so on as far as I remember. So so Pylint even does this as well, is it? I see. Okay, then let me see if
but don't
one.
don't delete it, right? I think it's
Okay,
valuable for us to see it, but I
I see.
guess I'm also trying to push you into thinking like, what are the
Like I
bigger
see.
things that you struggle with that you feel
I
like
see.
an AI
Yeah,
system would be able to help with?
yeah. Um, um, yeah. So I had some other use case. Let me think. So in terms of errors, so what else? So yeah. Yeah. Like okay. So like also like I'll write it and then you can again correct me if I'm wrong, or you can tell me
Oh
if
no,
there's any
it's
other
not
thing.
about me correcting you.
Yeah.
It's just
Yeah.
this
Yeah.
is
Yeah.
brainstorming, right? This is just,
Yeah.
you do this for a living, right? So we're just
Yeah.
curious to
So
hear about.
other thing is so on the arguments passed to a function.
Mhm.
Yeah, again I think maybe Pylint does it. Um, yeah. So it's again something like, if I recollect the bug, something like, there was previously self.node, whereas the method was expecting an integer.
Hmm.
But yeah, so where I should have done a length of something.
All
So
right.
apart from that, yeah, I'm also thinking, in terms of, for example, like I mainly, in terms of deep learning, coding such systems, whenever we use these packages, like let's say TensorFlow, PyTorch. So I'm thinking, what else? Hmm, so sometimes there's a bunch of mathematical operations. Um, yeah, I mean, so yeah, might be too. Yeah, I think that's it. Yeah, I think that's it. For now.
That's fine. That's fine.
Yeah, yeah, let's do next, right? Yeah. All
All right.
right. All right.
Great.
So, yeah.
Done. Good. So I guess you had some questions, and I also have like a little bit of debrief to tell you, the kinds of things we're studying. But I don't know what would you like to start with?
Yeah, yeah. So, um, yeah. So, like, I think I want to first take your opinion on this thing. For example, I think by doing both the tasks, I think, of course, as you might have foreseen, the task that you first start with definitely removes some block in terms of the end user. So for your test, that'll create some bias. I'm sure you'll actually work on, you would have worked on that by switching people. But for me, more concern was, you know, I think to test the AI system, the familiarity or the recollection of the underlying data structures in this case will have a significant impact personally, so maybe I now find it, it might be useful, if we spend, let's say, 10 minutes, at the beginning of the translation task, to look at both the data structures, so that's my thought. I want to hear your thoughts on this.
Yeah, I mean, just, to your first point, absolutely, we are randomizing the order and everything. So, you see the experiment from one participant's point of view, but we see it from, everyone's point of view. And
Multiple.
we do
Okay.
recognize that, if you get AI first or second, it matters. If you get, which data structure with AI versus without, like all those things matter. So we have enough participants and we've randomized the order that all of that kind of
I see.
cancels out when we do our analysis. Um,
Okay.
so yeah, so that's the first part. The second part on background is, we did try to pick things that, people, it wasn't totally new to people, but it wasn't totally fresh either, right? That's why we had that pre-screen where we ask you, like, when was the last time, you implemented this data structure? And if someone told us, oh yeah, I implemented it last month, um, that was kind of disqualifying because we didn't want it to be totally fresh in people's heads.
I
But the
see.
flip side of it is it almost shouldn't matter in a sense if you're familiar with it or not, because without the AI system, at least in our pre-testing, what we found is it's sort of easy to just turn your brain off and just line by line do translation without even thinking about what is it's supposed to
Yeah,
be
yeah,
doing. And then with the AI system, we kind of saw the same thing that, oh, it's easy to just take one of these things that the AI system produced and just try to run it and then just find out where the errors are, like without even reasoning about, what the data
yeah,
structure is doing. So for us, like to observe you, like spending a lot of time, like digging into the Java to try and understand what the code is doing, it's interesting because it tells us that that's actually important. Like you feel like you do need to have this understanding in order to do a correct translation. So that's why, part of the reason why I'm trying not to say too much ahead of time about how to go about the task, because we need to see how people are doing this.
yeah, yeah.
And really in general, right, the research is motivated by the fact that there's so many like AI for code models that are being developed that, they do things like translate from one language to another, or they do things like given code, produce documentation, or given some like natural language snippet, it'll write the code for you. Um, a lot of these models are being developed, but no one's really looking at, are they actually useful on sort of realistic programming tasks for a software engineer, right? The way they evaluate these models is there's some like blue score metric or something that tells
Yeah,
you, what the quality of the model's output is, but it's not telling us, well, is that actually like working for people,
yeah,
So we
yeah.
wanted to look at the situation where we say, well, we're giving you an impossible task. Do you actually get more done when you have the AI versus not? So that's kind of what we're looking at a high level. And
I
then I
see,
guess
I see.
the second part of it, right, is we're doing this study now, but we have other tooling that we've been building to sort of integrate these models inside of VS Code. So like we're building a plugin where you could actually, invoke the translator on your own code, or invoke, here's some
Nice.
code, give me documentation, because we want to look for those more like real world use cases that if we give this thing to you and you use it for real for, a month or 2 months or whatever, to see if you're actually like benefiting from it as a programmer, as a software engineer. So
I see.
since you filled out, you gave us your email address for future studies. That's what that's all about is, we'll when the tool's available, we want to make it available for people to try out for real and see if it's making a difference.
I see. I see. Yeah, yeah. I mean, I think overall, I think that's very good. I just have like two more questions.
Oh,
So
sure.
one, yeah. So what's the like, why did you guys prefer to have, let's say, five AI systems, right?
Yeah.
So like, yeah, in the beginning, I actually jumped towards, maybe trying to pick one, but when I compared two, I could see some differences.
Mm.
Then I realized, maybe, yeah, it's gonna take a good amount of time in comparing itself. So I just went
That,
with the idea that maybe the
yeah,
first
yeah.
system is the highest scored one. So
That's a fantastic question because um, one of the other things we're doing in this study is where some people are getting five and some people are just getting one. And the reason behind that is with the AI model, it's more often the case that it sort of finds the right translation amongst a set of like 25 translations. Like if you have the model produce 25 translations, then the likelihood that it translated it correct within that set goes up dramatically, versus if you
okay,
just pick one, the likelihood that that's a perfect translation is
I
much
see,
less.
I
So
see.
so we're also interested, if we give you a set of things that are, sort of different from, one another, is it easier for you to look at those and sort of look at the differences and try to pick one that's got the fewer number of errors in it? Or should we just give you one and don't overwhelm you with like all
Yeah,
these
yeah,
multiple things and just we know it's got problems, but you'll just go in there and you'll find the problems and you'll fix them.
yeah,
So that
yeah.
yeah.
I see, I see. Yeah, okay. Now I understand, and which I think makes sense as well. Yeah, yeah, exactly. I think the
Yeah.
overwhelming part you mentioned it, but I see the need for it. I see. Yeah. So then the next one was, maybe I think it might be easier if there are some test cases as well. For example, I actually felt like I spent at least 5 minutes, crucial minutes in the AI task to get the Java syntax correct. Maybe if I had that 5 minutes, I feel like maybe not just me, even some other person might be doing a better job as well. So maybe as part of the translation, even if the original code doesn't have any test cases, it might be a worthwhile thing, to generate test cases, in the translated code. Yeah. What do you think
Yeah,
of that?
it would be, I mean, right, that's sort of the holy grail, right? Is we see a lot of need for test case generation because there's just a lot of code out there, like especially legacy systems that, don't
Yeah.
necessarily have tests.
Yeah.
But there is work for, training AI models that are able to generate test cases. Um, it's not very mature and it's not at the level that we would actually be able to use it to generate test
I
cases
see.
in the study. But on the flip side, right, for what we're looking at, um, we're more just concerned with, can we just give you some code and see if you're able to work with that or not? And in
I
a lot
see.
of cases, when you have to do this, uh, there's this notion of application modernization, which is sort of the broad scenario we're looking at. A lot of the cases there, you don't have test cases. You're given code
Yeah.
that was written like 20 or 30 years ago by someone who doesn't work for the company anymore, and your job is like, take this thing and go port it to the cloud.
Yeah.
We've actually done a lot of user research around this where um, there's just some like legacy IBM product that actually one concrete example is there's a product that IBM has called Data Stage, which
Hmm.
is like it's a Java-based application that you run locally on your computer, and it's like an ETL product, right? It connects to a database, it pulls out information
That's
from
the
something, it puts it in
transformation.
it, right? So so there's actually a project going on right now to migrate that to the cloud.
I see.
But it's like it's not well documented. There are no test cases, and the guy that's working on this is like, he hasn't been with IBM for very long. This thing is probably older than he is. Uh, good luck.
Yeah. Yeah.
That's why, we're
For
thinking, well, how can AI models help with this, right? So maybe they can help port some of that Java code over to a new language, or in his case, he's also working on UI design things, and there's a whole mess of things about how do you translate the legacy UI design into the modern, IBM Carbon design system. That's a huge project. So that, we're thinking of various ways for AI to help out there.
Yeah. Yeah. I see. Yeah. Also, like I think I mean this is a very interesting task. I think I would also try to read like follow like more on this work. So
Mhm.
yeah. I mean, nice. Yeah. Okay. Yeah.
Yeah,
I think
great.
that's all I have. Yeah.
Okay. Well, thank you very much for participating. I know, 2 hours is kind of longer than we're usually,
Yeah.
running studies with. So I really appreciate you sticking with it. And also, I think I mentioned in the emails, I'm gonna send you some blue points to thank you for your time. And this
Yeah.
was really great. I appreciate it. So
Yeah. My
I
pleasure. I
hope,
think
I hope you had
that's
fun. That's
yeah, exactly. I think, yeah, I think that's true. I think I did have fun. So it's good. It's good to yeah, it's good. It's good. I spent this couple of hours. Yeah, I had fun.
good.
Yeah. Thank you, Justin. Yeah.
Excellent. All
Bye.
right. Thank you so much. Take care.
Yeah. Bye. Bye.